Hey guys. Hey guys. Can you hear me?
Hello.
Hey,
Hey.
morning. Hey.
Hey Suji.
Hey.
How's it going?
All right. All right.
Good.
Yeah.
So anyone have anything new and exciting or somewhat interesting to share? Oh, it's good enough too.
I got, well, I don't know what interesting. So spelling correction, I'm looking at it again. So it's actually, so the use case here is for an image search kind of application. So we have something called 3D for medical, which is basically, medical images, right? And like cross sections of the brain and more illustration style images, right? Is meant for education. And people can search for it with names, and they frequently misspell the names, right? And so the idea is that instead of giving them nothing, so currently they use Metaphone to do that. And the idea is that, instead of giving them nothing, you convert it to something that is a reasonable, the correct thing, and then you do a search on that, right? So the whole spelling correction thing is invisible to the user, right? So we automatically correct it and then give results for the corrected thing. And so right now they're using Metaphone, but the problem with Metaphone is that even though it does it uses sound phonemes, right? A set of phonemes and edit distance on those phonemes. It does not necessarily translate to something that exists in your database, right? Because the dictionary is not controllable by you. So the dictionary underlying Metaphone is not changeable, basically. So what I was suggesting was that, let's switch out Metaphone and use spelling correction instead. So and the thing is that sometimes the words you get are irrelevant and they give you like weird results also, right? So you don't want that, basically. So I was saying that, let's go with the spelling corrections, which so I've been asked to basically provide options, right? Different kinds of spelling corrections and do a true or a kind of do a little proof of concept if possible and so forth. So I was reading, so this is obviously the Lucene way, right? Where you break it up into trigrams and then you match trigrams and see how close you get. Then there is, you can also think about probabilities where, what is the probability of substitution or, deletion or whatnot. And you calculate the most probable correct spelling in that way and then predict it, or you can do a combination. One thing I came up with was using something like fast text and look for semantic closeness first and then filter by edit distance, right? So that's another idea that I'm thinking that maybe I can try out. And the other one that I read, I read a survey paper on it, and that is talking about a neural network. So essentially, you train the neural network in a self-supervised way. You have your vocabulary, you make corrupt the input and then make it predict the output in different ways. And the output is basically a big array of words in your vocabulary, and you do a softmax on it and get the most probable word and so forth. So that's new. It's still all in my head, not even on paper at this point. But yeah, so that's something I might be doing in the future.
So how do you do it unsupervised? Do you try to generate errors?
Yeah, basically. So I have the corpus of the person, this all the text corresponding to the images that I have in this database, right? So I have that corpus. I can use the words in the corpus. That's my vocabulary. I randomly corrupt the words, and then that is my input, and my output is the correct word, basically, right?
Right. So you got a training.
Right.
But I guess the trick will be in the corruption.
Yes. So usually, apparently, from statistics about misspelled words, there is like usually, people don't make mistakes of more than two characters in a single word generally. So I would stick to maybe that, they only do that. And so there is a second piece of this. So this is single word correction, right? So what happens if you have a, like a 4-word query term and you made, mistakes in the second and the fourth one. So you would actually have to find a path that is the most reasonable correction, right? Because you have changed 2 of them and you don't know which 2, or you know which 2, but you basically have like multiple suggestions for each of them. So even if you take the first one may be correct in the most probable one in one prediction, but when taken in conjunction with the other one, it may not be the best one. So you want to calculate the probabilities across the entire thing. So that you can do that with like maybe beam search, or you can do like Markov chains and then Viterbi backtracking, right? So again, that's the second piece that might would be there. So that's this is just a beginning kind of thing, right? So I wanted to just point, like mention it because that's the fun thing that is coming up my way.
So, I mean, this is not really a solution, but I mean, literally, if you could just use Google, their correction, it would get you 98, even though you're domain specific. I bet it would get you where you needed to be. Huge.
Probably, yeah.
So, I mean, the question then becomes, do we have any idea how they're doing it?
Yeah, I don't actually. Well, Peter Norvig kind of gives you a little taste, but I don't think that's what you're doing.
So, are there libraries? I mean, there might be a Python library that improves what you're doing by like 50% with almost no effort.
Could be, yeah. Well, there is the ASPEL libraries, but I want to. So one of the problems is with this kind of third-party library that it comes with third-party vocabulary as well, right? And it's usually quite hard to switch out the vocabulary for your own. And I mean, it's possible. We have done that once, but it at least with the Jazzy thing, we had to do a lot of weird code changes to make sure that it took.
What about Space? What about Spacey?
Spacey, I don't think has spell checking built in, but
No.
Lucene, you can use Lucene for that basically. So since it's a search application, Lucene would be actually right up. It's an unsupervised technique. You basically take your vocabulary, you break them up into trigrams, character trigrams, and then you basically, you take your misspelled or suspected misspelled word, and then you break that into trigrams, and you basically do a query, right? And depending on how many, so chances are that most of your queries, most of your trigrams will match. Some of them won't, and so you get the closest in ranked order, right? And then you can, but then you don't. It's semantically you don't actually have any guarantees. Although to some extent it is more of a guarantee than a completely third-party dictionary, because this is all trigrams composed out of your words, your vocabulary, right? So in that sense, there is some semantic guarantee, but you can move further and do the fast text thing where you look at the semantic stuff first and then do the edit distance. Just flip it around. So that's the the third thing, and then
This is, I mean, I don't know if this is any useful, but I did just post some project built on Spacey.
Okay.
But it does exactly. Yeah.
Oh, cool. Okay, nice.
You see what it does? What is it? It identifies out of vocabulary words.
Oh, using BERT. Okay.
Yeah, and then uses BERT, using the BERT model. BERT was, so it's just identifying misspellings, not correcting them, I think.
Okay.
It says, wait,
non-word error correction.
Context when correcting. So somehow it is correcting. I don't know. Take a quick look at it.
Yeah, I will look at it. Thank you.
Yeah. I don't want to ruin your fun. I'm sure. I'm sure it won't do everything you want. So I'm sure you're still safe. Nice. Very nice. Interesting. I like that corrupting and training thing. That's really cool,
Yeah,
right?
yeah.
'Cause it's kind of like self-supervision, you know.
Pretty much, yeah, yeah.
Okay. Anyone else or anything else, Sujit, on your end?
No, that's it. Yeah.
Anyone else want to share anything? Manny, what you been up to? Sorry. I don't hear Manny.
Can you hear me now?
Oh yeah, it's really loud though. Sound like you're in a manufacturing plant.
I'm sorry. I'm not really sure what my system settings changed. How about now? Is it okay?
No, it's really bad. We'll come back to you, okay, if you want, or keep trying. But it's yeah. Now it's kind of quiet when you're not talking, but when you talk, it's very distorted.
Okay, let me try it again.
Okay, so we'll come back to you, man.
I
We'll come
can't
back.
see anybody now.
Can you hear me? Hello, Yuri? Suji, you hear me?
Yes, I can.
Oh, so we got two. How many machine learning experts does it take to use a microphone?
It's just the Zoom settings that's what I'm messing it up.
No, Manny, you're still really bad. It's like really loud. It's really distorted.
Yeah, okay, gotcha.
You'll have to put it on mute. So he's gonna pop off and come back. Yuri, can you hear us? All right, well, let me see. I'm just gonna text to everybody in case he sees that. So I have a couple things, I guess, Suji, small things, but of some interest that I've been working on at work. Continuing on some of the stuff we talked about last week, but I'll show you a couple simple things if you'd like. I'll share my screen. And hold on, just mess that up. Oh yeah. So can you see my
Nice.
yeah, so here's one thing I wanted to show. It's just the elbow. We've talked about that before. You mentioned elbow graph clustering stuff, but I found a package that kind of does that, and I started to use it. And I just wanted to show you quickly. Okay, so what I have here, the context is trying to determine a cutoff. Of course, right? It was for threshold automation. It's a little bit of a funny example here, but basically what I have is prospects over the last 3 months reading on the TechTarget network, TechTarget sites, and how many pages have they read. Now, I wanted to try to get rid of the people that have done like, you know, a lot of pages, because it's just going to be too complicated to deal with representing their intent, what they're interested in. Now, it still might be possible after we talked about last week, you know, clustering the whole, you know, the whole data set and then seeing, I might be able to turn those into, you know, more than one intent. And so but what to start off with, I wanted to know is, you know, can I have some sort of cutoff without losing too many prospects, right? Simple thing. This is a prospect ID right here. So you can see this is a weird one. I mean, these guys, this is actually the most trafficked prospect. So this prospect in the last 3 months has looked at 1,453 pages. Something funny is going on there, right? Nobody's going to be looking at that many pages. So you understand this table here?
Right, yeah.
Okay.
Number of pages each person has read. Okay.
Yeah. So, you know, I just, of course, did a quick plot. You can see most of them are pretty small numbers. Almost all of them are here at like 0 to whatever this is, 20. Although they go all the way to 1,300 or whatever. So pages read. So what I did is I just, you know, I started zooming in on the plot. So here you'll see number of prospects on the left side. On the y-axis, on the x-axis is number of documents read, because I wanted to look at the elbow of it. As reverse of what's above, but so you could see the elbow looks like it's what, you know,
And it's a cumulative plot, right?
yeah. Is it a cumulative? I don't.
Because that's the only way you would get this kind of shape, no? Because
Yeah.
otherwise you get the peaky one.
Yeah, it's probably cumulative. Okay, I did this like almost the beginning of the week. So yeah,
Okay,
it's a cum sum. It says right here, cumulative.
Right, okay.
Yeah, it's a cumulative sum distribution. Thank you. And so what you see is the threshold. I'm trying to ID the threshold just by looking at it. So I'm just zooming in. You see, now I'm dealing with 0 to 3 docs that they've read and how many people. So I get a good idea for that of the 100,000 prospects. So, but then I wanted to see if I could say, you know, it's around, I could see it's around between 10 and 20, probably where I want to do the elbow, or maybe as low as 3. But so I use this elbow plot, this library for doing elbow to get the knee or the elbow. And you see right here, knee locator. That's what I imported from the library.
Cool. Okay.
And you give it your X and your Y coordinates. I'd say whether it's concave or convex. The direction is increase or decrease. And then this is some sort of parameter, which I put at 0 because it makes it less sensitive. You know, like it's measuring how much it's changing at each next step.
Okay.
It's changing. So this is, I think, making it really tight and really reducing or making it highly sensitive. So you get the, you know, so it decides it's at the elbow quicker, right, rather than later. And so I actually get a number out of it. So that's the knee, KN. And then I plot it, but I get 13. And so now I know that at 13 documents, I still have 101 and I have 101,000 prospects. So I'm missing about 3,000 prospects, right? Because there's actually 104,000 prospects. So that's pretty nice, right? I mean, it gives me a good degree of confidence that I can go at 13, and that's a reasonable number of docs. There may be a couple different intents in there. So, you know, I didn't really need to do this for this exercise, but it gives me a certain amount of certitude. And it also, when I'm dealing with document thresholds, you know, like in similarity query, you know, like when you do use a vector database and you get your results back, well, where do you put the threshold, right? So maybe this will work as a reasonable auto threshold setting.
Yes, I think that's a good point. I mean, you can also, I think you can use it for, so one of the applications I have for graphs, right? So if you can create a graph out of embeddings, document graph, and so it's a, you know, because it's a number between 0 and 1, you don't know, you know, everything is connected to everything, right? Even though it's one can be with an age weight of like 0.1 e minus or 1 e minus 5, and one can be like maybe 80, 0.8, right? So you want to, you'll get the similar kind of graph. I wonder if you can use that to cut off, you know, at a certain amount of sparsity.
What are you talking about? Not data's coming, not documents coming back from a SIM search. You're talking about
No. So let's say you want to create a graph out of a document corpus, right? And so one way to do it is basically take embeddings for each of these documents and then compute the cosine similarity between these embeddings, right? So then you would have a number saying, you know, between all documents and all other documents, which signifies, you know, how similar each of them are, right? And you could use that similarity as an edge weight to create a graph. But the problem with this graph is it's super dense, right? Everything's connected to everything.
Yeah.
And it's useless basically at that point because you can't do anything with that.
I can say you do a similarity
exactly
cutoff for the edges to reduce the density.
Exactly. Right.
Yeah.
So
if nothing else, it would be a quick initial shot at that.
Yeah, exactly. You know, I'm thinking the curve will be very similar. So I think the knee locator might be a nice way to do it. So
yeah,
good. Thank you.
Let me see if what the model is.
Can you with the knee locator, can you locate 2 knees?
So I have a use case for this. So I have a plot that first bends flat and then goes up. Can it locate both of them?
Yeah, you mean the direction of the
Multiple knees, I think. Yeah.
Oh,
Yeah. Yeah. So like I have a I have a plot where like it's first like growing slowly and then it flattens, and then it takes off almost exponentially.
oh, right. It's not a nice, perfect curve, power curve, or whatever. I don't know how well it would work on that, and that's a good question. And that S measure might help, right? Because if you make it less sensitive, it might get over that.
Yes, and that's yes, and
You can
that's
also
shape.
split it up between two graphs, right? Because it's like a tanh here, right? So if you can find a midpoint where it's, you can take it as like the left half and the right half, and one is convex and one is concave.
Yeah, and this is the library, so I know as much as you. They do describe the. That's not really. They do describe the maybe the paper it's based on and the algorithm as well. So it's just KNEED. Yeah, you guys can see what I'm doing here. Yeah, so I don't know. That's a really good question, but that's also a good workaround. So. All right. Any other questions?
By the way, I'm unfortunately like on the move right now, so I'm listening in the car, so I'll be like minimally participating.
Okay. Any other thoughts or questions or anything about that little utility? Okay. I do have something else, but I don't know what we got here. I don't know, Manny, if you want to try to talk again, go for it. Otherwise, I'll continue. Go give it a shot. Okay, well, we'll get back to you. Let me do this. I'll do this pretty quickly. Okay, so the other thing is Pinecone. Yeah, I could show how I use. It's just super convenient and easy to use. And by the way, Yuri, thanks for that link. I've signed up for that talk. But the interesting thing, right? So I can show a couple things just so you can see basically what I did here is what I need to do is go to the indexing part. All right, so here you go. So I'll show the basics of Pinecone. And that's just a batch generation. It's not important. But what I have are product pages from software vendors. And I have 14,000 of these product web pages, which have been, I use Boilerpipe as always, and Boilerpipe 3, and I get the text from it. So I have 14,000 documents, basically, each one representing a product page from a vendor site. That's my data. So what I do is I index that into Pinecone using, I started with this sentence transformer. So it's got a cutoff, like 160, whatever, 162 tokens. Okay, so I just give it automatically cuts the text is longer, it automatically cuts it. I also I'd have to use the tokenizer and figure out, because it's not like character length, but I did confirm that it just auto cuts it off. So I could you can give it as much text as you want and it'll cut it off. So I'm really using a sentence embedding for really for documents, but without doing anything fancy like splitting up into sentences, and, averaging it or anything like that. So I'm using this. I actually don't know much about this. I just saw other people use it for semantic search, right? This paraphrase. So it's just my first shot at it. I need to experiment. But what you do here is, so I get the text. That's not important. Let me work backwards from the indexing so I didn't prepare for this, but let me see here. So all I'm doing here is I'm embedding you don't need that. That's just me learning shit. So here I'm embedding the product pages. This is transformers, it's sentence transformers. So sentence embeddings. So yeah, I get my embedding model from Hugging Face, and then I embed or encode, right? That's all you do, you encode. And I'm just taking this data frame, the title body column of the data frame. Okay, that's got the text from the web pages, from the product pages, and I'm putting it in a list. So basically I'm just getting this array of all, 14,000 pages embedded. Okay. And it's it's like 380 something dimensions. That's what this embedding model uses. All right. This is classic Pinecone. You just, like you said last time, Suji, you're just embedding your stuff and throwing it in there.
Right.
Okay. So now I'm creating a Pinecone index called IBC. That's the name of our product, but IBC products. So it's, and I have to tell it the dimensions. So I'm using the embedding model, just to get, so I could programmatically set the number to 385 or whatever it is. And I'm saying the type of indexes, the metric we're going to use when it does querying, when Pinecone does the querying, is cosine. You can also do Euclidean.
Yeah.
But you know what else they had in there? I didn't quite understand, was dot product.
Dot product is just unnormalized cosine.
That's
So
a
unnormalized. So essentially, if you, if you had your sentence embeddings, if they were normalized to begin with, L2 normalized, then you can just use dot product. It's much more efficient because you don't have to do the denominator stuff. So you basically, normalize them ahead of time, right?
I get it. So probably the only reason to consider dot product, it's not going to be the quality of the results. It's going to be just cosine that's more efficient because you've already done the normalization in your vector space. So and that would be a question for the embeddings. Do typically sentence embedders, are those typically most of the models for embeddings from transformers, are they typically normalized? Do you know?
I don't know. I would just normalize it, as a separate step before I send it in. So I don't actually do it this way usually. I write them out into a file, and then and then I basically normalize it. Normalizing is just at the row level. You don't have to know all of it, right? You just have to make sure that the square root of the sum of the squares, you divide it by that, right? So,
how if I'm not normalizing and I need to, what kind of behavior would I see?
And if you use dot
similar.
product, you will see numbers that are not bounded by 0 and 1, right? It'll be more because you don't have the denominator.
Okay. Right. If my space isn't, you mean in general, or if my space isn't normalized?
If your space, if your vectors are not normalized, right? And then you do a dot product, it'll be outside the range of 0.
Oh, I get it. Of course, absolutely. So I'll know immediately.
Yeah.
Also, Euclidean, they say, is backwards. So the closer to 0, the better.
Mm-hmm. Yeah.
Okay. All right. So of course I did cosine because that's typical, right? So then, right. So I actually then created. So here you go. I imported it's just a Python library, right? I imported Pinecone, and then I can create an index. And it shows up. There's a GUI, management console, where that shows up. You can also create indexes in the management console. So now I have my index, right? So now I want to index all of my embeddings. And so I'm just instantiating my index here. So there you go. I've got an index object now. Can you see all this stuff? Okay?
Yes, I can see.
So basically just instantiating the index. And then I get a little information out of it with describe stats and describe. And you can see how many documents are in it. That's the number of 13,561 product pages. Okay. It's got replicas and all this stuff. Now, then I'm using a batcher because you can only do so many at a time. You'll get connection errors if you try to do too many index. And then I just batch it and index it. Here's upsert. You know what that, of course, is like MongoDB doc store language. And some of their stuff is MongoDB-esque. When you're doing what they call hybrid search, where you can use tokens, you could search on the text, full text with tokens. Outside of the vector search stuff, you can combine the two. They actually use MongoDB kind of language for doing that.
I see. Yeah.
What sort of DB underline are they using for this storing this embedding? representations.
Mute yourself, please. You'll have to mute. Could you interpret that, Sujit? I got most of it.
Yes, I think Mani is asking what is the DB, and I suspect it might be MongoDB as well, right? Because document DBs are kind of a good choice, right? Just like Lucene is like document level, but I'm not sure. I mean,
So
yeah.
actually, you're saying that a vector database is going to have a database behind it, right?
Well,
Like,
to associate the metadata for the document where you want to do the more traditional searching or filtering, right? You would need a
Yeah.
document-oriented thing, right? So
that makes sense. Yeah, it's got to be MongoDB because I know the syntax, and they use like the exact syntax. Whereas like your query is a dictionary, right?
Right.
And the keys are like like you've got variables in there and fields. And it's very. So they must be. It'd be interesting to know what their underlying infrastructure is. Okay, so then I indexed shit out of everything. It's quick because it's all vectors, right? It's all numbers, which is pretty awesome, right? Coming from an indexing,
right.
search index world, it's kind of fun. And then I just make sure I can run a query. And so take my text, I embed it on the same model, I just encode it, right? And then I query, and you just use the index object and you query. And I'm converting the array to a list because they need just a list. And the number of results, and then you can include the vectors for each document that comes back, but I don't do that. So I mean, it's pretty simple, right? It's just very scalable and easy to use. I don't show results there, but let me see here. I do some query, it shows some results here.
Wait, could you go up a little bit? Sorry.
Sure. Yeah.
I'm looking at the results. See how it is. Yeah.
Are those the results? I don't think those are the results.
Okay.
They're just showing the data. So
I see. Okay.
I'm trying to find some results here. Maybe what happened is I kind of got mixed results. I got a little concerned about the results. So yeah, I don't have any to show you there, but let me see here. The interesting thing is symmetric self-time. Okay, so here's what I did here is I just, this is interesting. I wanted to share this is, and I don't have results show there, but the interesting thing is I got some mixed kind of results. And so I'm like, how do I know my index is worth a damn? You know what I mean? Like, is it a good similarity space? Maybe it's just shit. So let me see what's going on with this here. Okay, we've got some questions here. Yeah, it says, what about tokenization part? I'm not sure what the question there is, but the Manny, but the tokenization is all happening under the hood automatically because I'm just using transformers. So you don't tokenize the text, you just directly encode. So when you use that transformers model or that sentence embedding model dot encode, it just takes the text and it's using the tokenizer that's associated with that model to tokenize it. So it's completely invisible to me. Although you could do the same thing in a way that you use classes instead and you use the tokenizer. So I hope that answers your question. Okay, cool. Okay, so right, I don't know, I have no control over this. I'm using someone else's embeddings. And the documents I have too are kind of sparse in a way because is it really covering the full breadth of products that are out there in the world? And so I'm seeing weird behavior. I'm not sure. So I'm like, how the hell do you test this? How cogent your similarity space is that you've created in these indexes? So what I did is I did a self query.
Mm-hmm.
You know what I mean? So basically, I took every document. Every product, all 14,000 of them, product page, and I ran it as a query and found what position it returned in its own results.
Oh, so getting like an all pairs results for each. So basically, you took each document, took its embedding, and
Yes.
found its nearest neighbors.
Yeah, I found its
Okay.
results or nearest neighbors from Pinecone, and I said, well, ideally they're all at 0, right? I mean, 1 at the top position.
Oh, themselves, yeah. Okay, yeah, okay. But that
So-
should happen, right?
Well, if the space is solid, I just want to make, I want to know, is the space that I index actually predictable?
Right. Okay. Yeah.
So it
The
builds
space
my
is
confidence in the
solid, yeah.
space.
Yeah.
I mean, I've seen them do this before, like in Gen 6 stuff. So
Okay.
they do. But so what I do here is, you could see, I'm not going to show how I do it, but basically just, it's easy, right? But it wasn't easy to get it to work right, but it's easy conceptually, just embedding it, running it, getting the results back and doing it en masse. And so here's, the distribution in a table. And so there's 10,000 of the 14,000 documents ended up in position 1.
Oh, okay.
So like their self position or whatever, right? Their self query position is position 1. That's good, right?
Yeah.
Pretty good confidence in that. We could do an elbow in this too.
Oh, this is the approximate bit. I think, okay, I understand now. So ideally, if it was not approximate, right, then you should have got everything at position 1, right?
Yeah.
Because it's
yeah.
approximate, it misses out certain times, certain
Yeah.
number of times. Okay, got it. Okay.
So I think with the approximate, what you're expecting is it should, almost all of them should be,
Yes.
first couple
Right.
results. I mean, then you have a predictable similarity space. That would
Right.
be, I guess. And
Well,
maybe
if it is not approximate, I mean, it's mathematics, right? I mean, you have 2 identical vectors, the cosine similarity has to be 1,
okay.
right? So, yeah.
So in a way, this didn't really tell me that much, but it did build my confidence in the
Right. But it still doesn't tell you about the quality of the embeddings, right? Because so usually this is something I have found out, and my results may not be completely typical, but it's general trend typical. That if you use like a non-fine-tuned thing, right, and you try to just use it as is, your results may not be very good. But so essentially for neural search, they recommend that you fine-tune it on your content, which means label data and so forth. But my results were terrible with like non-fine-tuned, and I didn't get the blessing to go and fine-tune it. But other people have had better results than I have, right? So I mean, that's another thing. So maybe fine-tuning is something that
yeah, and of course, what I need to do is prove viability before I go down that path,
right?
Right, because that's something I would actually have never fine-tuned the model, and that would be fun and exciting, but I can't do that yet, right? Unfortunately. So that I need to do that though. But first, I need to prove the reasonable viability for this thing. I am getting good results.
Okay.
Pretty good. It's inconsistent, right? It depends on sort of the density of the space, right? So if I'm searching on a topic name or on a title or whatever, if I'm searching with text and that text is like data backup, I just get a ton of great results, right? Because there's just a ton of products out there on that, right?
Okay.
But if I do something like that's more sparse, I get less. The results become, the ranks are lower when they get, but they also just gets less predictable at the sparse level.
Okay. Yeah.
Okay. So, here you go. Here's some results. These aren't great results, but pretty good. So this is where I'm testing results, I think. Yeah, and you can see here that I'm querying on, it's interesting, I'm querying on, I don't know what the fuck I'm querying on right now. Let me see. DF results. Okay, here we go. Here's where I define it right here. So I'm taking, I guess what I'm doing, I'm taking document 3,333. I'm embedding it. And I'm saying what its position should be according, because the test I just ran above, I know it should be position 1. But what I do is I'm actually doing something funny here. I found that the results were hugely biased when you use, if you have the product name in your query.
Okay.
It's called Creative Workflow, and Binder is the company name. Because this whole embedding space is so focused on product names, right? Because all of those are product pages. And so the problem is if you use the product, if you have the product name in your query, all your results are just that company's products, not really based on the type of product you're looking for, right? So what I do is I had to remove those from the query, and then I would get a good ranked result. So in this case, I don't know what these guys do, but there you go. It's DevOps. This is a DevOps query, I think. So you can see that when I did, actually what I did is I overrode all that. And I started doing right here. My query for this is just the word DevOps.
Okay.
Yeah. So, ideally I want a representation of what a prospect's been reading about, and then I want to use that as my query. So,
Okay.
so I'm actually getting pretty good results with some things, not as good with others, like really good results, right? So I actually can look here at so these are the companies. You see the domains above here?
Mhm.
That's the count. I only did 10 results, so it hardly counts in this case. But so I can see what companies basically have products in the DevOps area. Okay. So anyway.
Yeah, the sparse versus dense observation you made, it could be related to, so this is something I thought about earlier, where you think about it, neural search or pinecone based approximate nearest neighbor search, it gives you nearest neighbors, right? But your nearest neighbor can, if you live in a city, your nearest neighbor is like really close, right? But if you live in the countryside, your nearest neighbor is really far, right? So it's in the same sense, right? If it's a sparse area of the graph or area of the vector space, then your nearest neighbors are not actually semantically near, right? They may actually be pretty far from you.
Yeah, so. Yeah. And the funny thing is it also kind of gets unequal too. Like the ranking, it's not. So the question then is, when I run a query, I have an embedding, right?
Right.
For a query. Is there any way? So I've always, I've tried to resolve this with threshold. That's why I'm always like automatic thresholding. And so, because each query results where there's no absolute threshold. I know it's 0.
There is none. Yeah, that's the thing.
But it really depends on the sparsity of the query. So is there a way to take your query and measure its sparsity, or measure its chance of producing good results versus not?
You could look at the cosine, the similarities, but those are not, I've tried that. So basically looking at, trying to figure out, below this, I will not consider. It's imperfect. It's not a good measure.
There's no real way at query time to say the type of query this is. This
exactly.
query that's just not going to perform great. So just take the top 2 results. You know what I mean?
Usually that's the best, solution. Even the top 2 results may not be as good. Yeah.
But how can you tell if it's a sparse query?
So one way to do it is to basically, do a combination traditional plus neural and use some amount of, basically combine their scores, right? So, and try to get that.
Combine what scores?
Combine let's say you're doing traditional Lucene stuff, right? Same query you send to a Lucene index and you send to a vector-based index after vectorizing. And then you take both the results and then you take the scores associated with each result. So Lucene scores are again not normalized to 0 to 1.
No, I get it. No, I get it. They actually have a notebook for this, which is old, the Pinecone guys, where you basically are benchmarking against the sort of a standard search.
Right. Yeah.
Right. But you can't really do that. Can you do that live as you're querying? Like, so query is going to come in. I guess if I'm doing this all in batch in the background.
Right. Yeah.
It's not too bad. So you're saying benchmark against traditional search, and you'll see a pattern where if the benchmark, whatever the metric is that comes out of that, is below a certain point, then I've basically classified my query as a sparse query.
Yeah, that's one way to do it. Sure. I mean, I was actually thinking in terms of interpolating the scores. So you say alpha times the vector query, the cosine similarity, plus 1 minus alpha times the Lucene score, right? And use that and you select different values for alpha between 0 and 1, and you try to figure out which one works best for you in terms of what is the right results, the ranking that you want. Right? But again, that depends on, you need to have label data for that. You need to know what is the right thing.
So you were talking about re-ranking, kind of?
Yes, basically re-ranking.
Yeah. It's kind of weird. I guess you're trying to get the best of both worlds, basically.
Yeah, kind of.
Yeah. That's, I can see that. Okay. All right, guys, that's my sharing. I don't know if Manny, what you sound like now. You can give it another shot.
How about now?
It's terrible. It's terrible. But Manny, you could post anything in our chat you want us to talk about or anything right now, or else. I guess. Does anyone have anything else to share that they could share either by chat or?
Actually, I have a quick question, and the only thing I wanted to share is that there was a NVIDIA conference this week. I haven't listened to anything, but I'll go back and see if there was anything interesting. But my question to you is this: so basically, for now, you're using Pinecone to actually find neighbors based on distance, and then use the non-semantic search. Is that correct?
No, I'm just using Pinecone as a similarity search engine. I mean, I'm just simply putting in a text that's been embedded and then getting back the results sorted by cosine.
So it's okay. So you really didn't need with sentence transformers give you that by itself, isn't that?
Yeah, it gives me everything. I mean, sentence transformer, because it's my space. I didn't fine tune it or anything. I'm just using that. And
but I mean, they also have a method you can basically now
send the query on the document, right?
Yeah, you can basically get the ranking or.
So it's not cosine similarity?
No,
it is a similarity score.
Whatever they use, I don't.
So that's a good question. So the question would be actually, within Pinecone, can you define your own custom score and then maybe try theirs out? I think that's what you're saying. So the thing about Pinecone is they only offer, if they offer a custom score, that I think they do. I don't know how to do it, but they have those 3 scores, cosine, Euclidean, and distance measures, and those are the scores you get back in the dot product. You can get one of those. When you create your index, basically, you have to tell it which one of those is your metric. So I don't know if you can, so it's a framework where maybe you're giving up some of that flexibility. I don't know, because it's so easy to use and so performant.
No,
but it also has its own like non-semantic search. Is that true or no?
It's
only semantic. So you don't have any like BM25 mixed in there.
That's a good question. I can't remember.
Okay.
You could do. That's a good question. So look, Haystack is fucking amazing, guys. I mean, I haven't tried it, but I watched a really good YouTube video on it. That's the one where I forwarded, I sort of misanswered or sort of half answered Manny's question about generative QA. And in that Haystack, they show how to do generative QA using Haystack, and they explain what it is. It's pretty awesome. But really, Haystack is a lot more than Pinecone, right? Like I didn't understand before. Really, Pinecone is just, it doesn't have that whole reader, all that stuff, where you search and you read and you have a pipeline of different things. I mean, Jesus Christ, fucking Haystack is like an entire NLP factory in and of itself, practically, based on this, this vector space thing, this vector database, vector search. I think that thing is amazing. So this definitely doesn't compare to that. But I take your point, Yuri. There are more native ranking capabilities out there to sentence transformers. And the question would be, can I use that in Pinecone? And
You could use sentence transformers to re-rank, right? Because a sentence transformer will take a batch of queries and documents. So assuming, and that would be a fixed batch size, right? So you couldn't use like, all of your data. So maybe what you could do is you take the output of a traditional search, take say maybe 32 or 64 or whatever your batch size is, and you stuff it into the sentence transformer and it re-ranks it for you, right? And
yeah, so I'm using Pinecone for its scalability, right?
Right, yeah.
But then, of course, re-ranking is on a few number of documents, so a lot more becomes possible there.
Yeah, and then you just sort it by the scores.
I mean, that's actually a good way of just understanding the viability, whether it's going to help you as well. Even if it was something I could do custom in Pinecone and it was a pain in the ass, right? That I could even just do the re-ranking at the very basic level. So, but the main problem will be with the sparse space, if that'll even matter. Sparse queries. It might. Okay. Anyone have anything else? Nothing you read or saw. All right, guys. Well, Manny, you get planned for next week. Oh, he's gone. We lost him. All right. So I guess that's it, guys. Thanks. We'll talk next week.
Cool. All right.
Have good weeks,
Thank you.
everyone.
All right, you too.
Take it easy.
Bye.
Good
All right.
weekends. Bye.